What I'm going to talk about is software supply chain risk management, but the abstract that was in the tracker, it says it's about SBOM. That was another presentation that I submitted, and the organizers said to me, we have something on SBOM, but we saw this article that you wrote in Information Week about the elements of software supply chain, and we'd really like you to talk about that. I said, fine. But so you got the wrong abstract. I hope you're still interested in the topic. My name is Anita D'Amico, and I am at Synopsys. For those who aren't familiar with Synopsys, Synopsys is a publicly owned company. It's about $5 billion. It is a semiconductor chip design company, primarily. But there is a small business unit, about $500 million, which is all software integrity. It's called the Software Integrity Business Unit, and it is all about application security and securing your software and anything related to that, both services and products. And I am fairly new to Synopsys. I'm the Vice President of Cross-Portfolio Solutions and Strategy, so I'm dealing with big problems like software supply chain risk management, and that cannot be solved by any single product or service, that it really takes an integration of a lot of different people, processes, and technologies in order to solve that problem. So that is my mission. I came to Synopsys in June of 2021 when Synopsys bought my startup. So I mention that because for those of you who are parts of startups and you want to know what that journey is like, I have lived that journey. I started out with a $99,000 6-month research project that was funded by the Department of Homeland Security and grew it over time. A lot of it funded by grants, but not all of it. Bootstrapped it. We spun out a company. We got venture capital, which is not easy. And we got venture capital. And we were about to get our second round when Synopsys made an offer. And so for anybody who wants to talk about what that journey is like, I would be happy to share all of my experiences. They say that VCs only like to fund CEOs who have been down that process before. And now I understand why. It's difficult. The other thing I wanted to tell you about myself is that I don't have the typical background of probably many people here. That PhD is in experimental psychology. And it just goes to show that you can have a career in this field no matter what your background is. And then Ariel's here, and she has a cognitive science background as well. So, I mean, we could talk maybe in the Q&A if you want to know how I got involved in that or what the relationship is between psychology and software supply chain, risk management. But, I'd be happy to tell you that story. So that's just a little bit about myself. And now I'd like to talk about what is involved in securing a software supply chain. So let's get started. Everybody's talking about this. It's in the media, it's in conferences. They talk about software supply chain security and SBOM. SBOM is like everywhere now. That's software bill of materials. But what's it about? Well, I want to first of all talk about the software supply chain, because one of the questions that I get is, well, isn't that application security? So let's take a look at it. The supply chain is like any other manufacturing supply chain, whether you're manufacturing software or cookies to some extent. And there's a design process where you have your requirements and architecture and threat modeling. And then there's the development, which is the manufacturing process. You have an assembly line, which in the case of software is your DevOps pipeline. And you have the parts. And the parts are your custom code, your open source, and those other third-party pieces of software that maybe aren't custom or open source, but they come from someplace else. And when you look at the supply chain, you know who your developers are of custom code. You sort of kind of don't know who your open source developers are. You know something about it, but they're largely unknown. And your third-party software, commercial off-the-shelf software, has known suppliers, but you don't necessarily know where that stuff came from. And so then, after you've developed, you release. Now, I understand that there's continuous release cycles. You know, this kind of iterates around. But let's be simplistic and say there's a release where you have your executable code. But the supply chain doesn't end there. It goes into deployment. And your software inherits certain risks from its deployment environment, whether it's mobile or cloud or on a server or even a cyber physical system like an IoT system. And then there's also other stuff that gets pushed into the deployment. There's other third-party software that comes in. And then finally, there's the maintenance, where you have upgrades and patches. And so that's kind of what the chain looks like. And the important part about this is that every single link in this chain can be compromised. If you look at the well-known attacks that have happened in, let's say, the last 5 years, there are all different parts of this chain. So there was CodeCov, which is a code coverage tool that was hacked, and there were about 22,000 customers that were affected. You have the Log4j vulnerability, which was subsequently attacked, and that's in there, and that was throughout the supply chain. And then there was SolarWinds. SolarWinds was a big attack, and that's actually the one that got a lot of attention from the federal government because it went right into networks. And it was a software supply chain attack that resulted in major breaches in networks. So every link can be compromised. And if it's compromised early on in the process, the impact is felt later on in the process. So, but why, is that the only reason that that it was getting a lot of attention? Well, no. I mean, there's the attacks, there's vulnerabilities, open source software, the fear of litigation, standards, and a lot of federal procurement and industry procurement requirements. So let's just take those apart a little bit. This is why there's so much attention being paid to software supply chain. So the first is the attacks. You know, I just mentioned a couple of them: SolarWinds, NotPetya, Log4j, and vulnerabilities. Like Log4j, it was a vulnerability that was in open source software, and that was in 50% of all enterprises. So when this vulnerability was discovered in Log4j, 50% of the enterprises around there were running around saying, do we have it? And what are we going to do about it? And as soon as it was announced, there were all kinds of exploits that came out. And 40% of global networks there were attempts to exploit them within just a few days of Log4j vulnerability being announced. And Symantec blocked 93 million exploits in the first 12 days following it. So just knowing what your vulnerabilities are is important. And then the thing that's getting a lot of attention is open source software. 96% of code bases contain open source software. And in fact, there's an average of almost 600 open source components in every application. And you don't know who the developers were. There's a limitation on how far back you could go into open source in terms of provenance, which it still makes it worth it to bring the OSS in, but you have to be aware of what the risks are. In fact, 84% of those open source components contain at least one vulnerability, and about 48% have high-risk vulnerabilities. So when you bring open source into your supply chain, into your software, you are inheriting those risks, and you have to be able to find those vulnerabilities before you incorporate it. Replace it with a component where it's already been fixed. So these are some of the reasons that people are getting so excited about software supply chain. And then there's the fear of litigation. If you have not taken good practices in trying to secure your software supply chain and something happens with that software, you may be liable. But even the easy stuff, like checking licenses, is something that people will litigate over. And in fact, if you look at it, you'll find that 54% of code bases have some kind of license conflict or improper licensing. And so the lawyers get excited about it. And then finally, and this is what's really driving the market, the people who are interested in making money off of this, is there are standards that are emerging in verticals like automotive, medical devices, where they're saying, you know what, you have to secure this. And in fact, good thing. I mean, if you have an insulin pump, right, you want to make sure that the software that is in there was secured throughout its development. And so there are now regulations that are coming out and standards in these regulated industries. But also, the big thing that has changed is that in 2021, the federal government, there was an executive order that said, we're getting sick and tired of this, these software supply chain problems on our federal networks. And we are one of the biggest purchasing powers in the world. And we're just going to start requiring that you secure your software and that you secure your total supply chain before you sell your software to the government. And since June of 2021, slowly what's been happening is that different parts of what you need to do to secure your software has been coming out. So starting in June, this June, if you are selling software to the US government, or you are selling software to somebody who is selling software to somebody who is selling software to the US government, right? You will have to conform to certain guidelines. And I'll talk more about that in a few minutes. But that's what the big deal is about. And you might say, well, okay, so it's the federal government. What does it really affect? See all that stuff in blue? That's what it affects. When you go look at the guidelines for what you have to do in your software supply chain to make sure that your software is secure, it is affecting all these things. Threat modeling. Everybody likes to say, oh yeah, threat modeling is so important, but like we don't do it, right? Right? Yeah, we did it last year, right? Well, these new guidelines are saying you need to show your threat model and the requirements and track that. Then there is the parts. Okay, now at Synopsys. We build scanners that scan custom code and open source and all that. There's plenty of business now. That's been going on for years, for decades. But securing your DevOps pipeline, being able to attest that your artifacts are secure and that they have been tamper resistant is part of this. And then you get to the release. Now this is where SBOM comes in, because when you release your software, you will now be required to basically produce a parts list. And that's what a software bill of materials is. It's a parts list. And it's not just the parts of open source, which is what most SBOMs produce. Here's all your open source components. You have to show what's in your custom code, what came in from that third-party suppliers, and do all that. And disclose vulnerabilities. And this is a big thing, because do you really want to disclose all your vulnerabilities? Suppose that you have taken good practices to ensure that that vulnerable piece of code is never called. Do you have to disclose that? Right? So there's all kinds of things going on with that. And security attestations. This is a big thing. And if you take nothing else away from this, take this away. That it will not be enough to secure your code, to secure the pipeline, to check all your vendors. You have to attest to it. So somebody in legal, right, is going to be on your case going, did we do this? Do we have evidence of this? So that's part of the requirements. And then it percolates these new standards and procurement. They percolate through to, there's certain things you have to do in the cloud, and you have to be able to automatically monitor vulnerabilities in code that has been released. So now you receive code, you receive a product. You're going to have to monitor it to make sure that if the next log4j comes out, whatever the next one is, that everybody goes, oh, I didn't know there was a vulnerable component there, that you have to be able to scan all your SBOMs and know that you got one of those. And you have to have a certain SLA to fix it. So that's what the fuss is about. And SBOM, which is what's getting all the attention, is just one part of this. So people say to me, well, isn't this AppSec? Isn't this application security? This is like what we should be doing. Yeah, sort of nada, right? Because it's this part over here where you have the purple, where you have architects, AppSec managers, the dev team. They're the ones who are doing that software security, the AppSec part. You got a whole nother set of people whose hair is on fire right now about software supply chain. You've got the CISO who has to report to the board, right? Because the board is seeing this stuff going, what's all this stuff about? Well, we have risk. The risk officer. The risk officer is that person or the person who is the product security incident response team, the PSERT. One of those is going to have to attest that, yes, our product has gone through all this. So they're on the line. You have your IT operations people who are now inheriting. They realize, I'm inheriting all this risk. Tell me that it's not there, and prove to me. You gave me this SBOM. You told me this is the list of ingredients. How do I know it really is? Prove it, right? So you have all those things going on. So there's a lot of people now involved in this that weren't there when it was pure application security. Before I move on, are there any questions right now? Yeah, go ahead.
A couple slides previously, you had the number about the 54% of the cases have license conflicts. How many of those actually turn into lawsuits? Do you have a sense?
So the question is, of those 54% that have license conflicts, how many turn into lawsuit? I don't have an exact number, but I'm going to tell you probably very few. And that's because it gets flagged. It gets flagged. If you're doing a good job, you're going to flag it. So let me give an example. I'll tell you where that number came from. All right? Synopsys has a small business that is purely for mergers and acquisitions. And before a company is going to buy a target, right? The big company's buying the smaller company or any size. They want to make sure that they're not going to inherit any legal problems. So they come to Synopsys and they go, we become the third party, uninvolved, right? And we take their code and we check it for things like license compliance. And then we do thousands of these a year. And so it's called Black Duck, right? And so they so if your code's been Black Ducked, that means that it was scanned. And when we looked at all those, we found that 54% of those code bases had licensing issues. Now, the pre-acquisition. Now the acquisitor, the one who's acquiring, is going to make sure that all of those are fixed because they're not going to inherit that legal. But that's how we know. That's what the number is. And they're the ones that somebody has gone through the effort of auditing. Right? You don't know how many didn't get audited. So this is kind of complicated. And people, when I started looking at software supply chain risk management, maybe about 15 months ago, I started saying, this is like, my head is spinning, my head is spinning. And so about 15 months ago, I said, what is it all about? Like, are there just a couple of things that all this gets distilled into? And first I came up with like 10 things. And then I basically circulated around, and for like the last year, I've been presenting, this to various people, and no matter who I presented to, like we've only added 2 things over the course of 15 months to this list, and almost everything fits into this. So that's what I'm going to go through. So I'm going to group these by who should care. Right? If I gave you 12 things, you'd go, oh, that's just too much. Head in the sand. I'm not going to deal with this. But really, it depends on who you are. So if you are the operational people, the IT people, of all these 12 things, here are the 3 things that you have to pay attention to the most. And that is asset inventory. You need to know what software you have. And when you do this, you're going to find stuff that you didn't know you had and you probably don't want. SBOM. You need to be able to produce and manage a software bill of materials. That's the list of ingredients. And basically, if you're operational IT, you want your supplier to produce it, and you, as the IT operator, need to manage it. And by the way, you're not just going to get one SBOM from one supplier, you're going to get 10,000 of them. So they have to be put into a repository and indexed and queried for every time there's a new log4j that comes out. You need to be able to check that by repo. Yep.
What if they do 30 releases a week? Then you have 30 times 10.
So it depends on how you negotiate what SBOM you want. Like, it could be that the supplier only has to produce an SBOM for major releases. So that's something that is between the supplier and the procurer as to which ones you want. That's it. And by the way, we'll get into it, but there's a whole bunch of different types of SBOMs. Depends on when you produce it as to whether or not it changes a lot. Yes?
When you say provenance and origin, do you mean who or where, both, or both? And then, or do you mean like open source or third party?
Open source and third party is absolutely essential, but that's not a fine enough granularity. You need what people want to know is, first of all, who the supplier is. When you produce an SBOM, you need to know who the supplier is. So you have to name the supplier. But it is either, people want to know either where it was developed, and often they want to know what country because of export laws. And that becomes a legal issue. Certain places you can't develop, you can't bring in code that was developed in Russia, for example, or North Korea, China. And so depending on who is procuring the software, there are different rules about that. So you have to be able to mention that provenance. Okay, the next 4 is if you are a producer of software, you better do this. Yeah, this is like, you have to do the other stuff too, but like, this is where you want to put your attention. A secure development environment. You need to secure that pipeline and the artifacts. You need to be able to attest to the integrity of the software, that that hasn't been changed, that hasn't been tampered with. You need quality control. Are there bugs in it? Are there reliability issues? And then security. What are the security issues? So those are the 4. That's your pretty much standard AppSec, bread and butter. Then if you're the procurer, here are the things that you want to ask. Of course, you want your SBOM, right? But you want to know about regulatory non-compliance. And I say non-compliance rather than compliance because you can never actually prove compliance, but you can prove non-compliance. And so you want to determine if there's any obvious non-compliance with regulations or with industry standards. Licensing non-compliance. We already talked about that. That's a big issue. And unexpected functionality. Is there something in this code that I wasn't expecting? It could be malware, but it doesn't have to be. It just could be hidden functionality. Maybe it's calling home, and it shouldn't. Right? Doesn't mean it's malicious. but you want to know about hidden functionality. And then the last thing are the governance people, your risk officers, your legal people. They want to know, do you have a policy? If you don't, you got to build one. And did you conform to the policy? It's all about conforming, right? It's all about attestation. You had a policy, everybody agreed, yep, that's a good policy, it's a best practice, if you followed it, things should be pretty good. I mean, like 90% there, right? You took reasonable, caution. But you have to be able to demonstrate that you followed the policy and report it. This goes back to something I think, Ariel, that you were talking about earlier, is you need to be able to put the information in the form that the risk officers understand and can read. And so there's the risk management reporting. So that's it. Those are the 12 things that are involved in the software supply chain. And all the attention is being given on SBOM, and that's just one of them. It touches the other things, but that's just one. So let's go on a little bit more into SBOM, because everybody's talking about it. What's in SBOM? It's a list of ingredients. It's the list of ingredients that's in the software and that your software depends on, and that those components that are in your software depend on, and that they depend on, and that they depend on, right? So that if you have a component that calls 5 things, it depends on them. You have to list them. And if each of those 5 things call another 5 things, you have to list those. And so you have this tree. So that's really what an SBOM is. Now, many places only produce an SBOM for open source, because traditionally, that's for open source is most of your software. So, if you produce an SBOM for your open source, you've covered 80% of your application. But nowadays, what people are asking for is what I call the full Monty SBOM. Reveal it all. Just let it hang out, right? It's got to be open source, custom components that, your proprietary code, your base images, and your firmware, and your third-party libraries that might be commercial or freemium. All of that has to go in. And you have to have those information about the transitive dependencies, that chain, and the licenses. All right, so you need to be able to put what the license situation is, and it has to be in a standard format. There are 3 standard formats. 2 of them are really popular. The other one, SWID, is, I hope there's nobody here who's a big SWID proponent, but 90% of it is like Cyclone and Cyclone DX and SPDX. Cyclone DX was started by the OWASP group, and SPDX there's an SPDX Foundation Council. And you can, almost any good software composition analysis tool will generate an SBOM in these formats. What you want is one that's going to give you a comprehensive full Monty SBOM. And so that's what you need to have for an SBOM. All the stuff in a standard format. Now, depending on your industry, some want a little bit more, some want a little bit less. Like there's 6 minimum fields, but if you're in automotive, they want to see this. If you're in medical devices, they want to see that. So there is a tailoring to the SBOMs, and you should be able to get a software composition analysis tool that tailors as well. Now, one other thing about SBOMs is that there's different types. And in fact, I built this slide before yesterday, because yesterday, the Department of Homeland Security came out with a document that actually lists like 8 different types of SBOMs, right? So I have to update this, right? I mean, I knew they were coming out with it, and so we built the slide kind of based on that, but then they really came out with like, and so like sometimes you want an SBOM that you do during development for development purposes, or a build SBOM. Most people are asking for a packaging SBOM, which is you release your software, here procure, there you go. But some procurers or some IT operations people want to actually know, I want to know everything that's involved in that software in its runtime environment. What is actually in that when it's running? So that's a runtime. So I'm not going to go into any more detail, but just be aware that not all SBOMs are created equal. I want to spend a little bit more time on attestation, because this is a thing that if you are developing software, if anybody here is developing software and you want to sell it and make money at it, right? Somewhere along the line, it's probably going to wind up, you know, with a big purchaser, like the government or some other really big companies, right? And you're going to have to know this, because the government and industry are requiring self-attestation. That self-attestation means, I swear, honest, I swear, that this was developed, you know, according to good practices. And so you can't just say, yeah, it was developed. They're going to go, well, did it do this? Did you do this? Did you do this? So what is that? Well, all of this started in June 2021 with the president's executive order. And they said, you got to attest. So then people said, well, attest to what? They said, wait, we're going to tell you. And in 2022, the National Institute for Standards and Technology, NIST, issued a document called the Secure Software Development Framework, SSDF. You're going to hear these letters, SSDF. SSDF says, here's what you need to do. And while the government hasn't actually said yet, it's this. This is the SSDF that you're going to have to attest to. They haven't mandated it in law. Almost everybody thinks that's what they're going to do, and they have to do it by June. Right? So if you wait, like, you know, just 8 weeks, you'll know whether or not I'm right or wrong. Okay. And so that's one of the things. If you are selling or if you have an interest in medical devices, then the FDA has its own set of requirements. So those insulin pumps and those MRI machines and whatever it is, anything that is connected to the internet in any way or is in any way connected, the FDA has a firm set of software supply chain requirements that you will have to prove. The government is just asking, most of the stuff on the left is just self-attestation. The right, FDA, is saying, you know, when you bring that truckload of documents in for your medical device approval, well, you got to like have all the evidence in there that shows that your software supply chain was secure. So what's in this thing? It's not rocket science. I mean, you're going to look at this and you're going to go, yeah, really? Prepare your organization. Yeah, have the right culture. Protect the software. So make sure that, you know, your software, and when you're developing it, you know, it's tamper-proof. Produce well secure software. You know, perform testing on it. Make sure that you bring in secure, reliable components. And then respond to vulnerabilities. And they're getting a little bit tougher now in that you have to demonstrate that you will be able to find vulnerabilities in production and remediate them beforehand and find stuff afterwards. And of course, it's the government, so it's never going to be just those 4 things. Each one of these 4 things has practices. Like this one right here, produce well-secured software, has 9 practices. And then they have tasks, but they even give you examples. They say, you know, you want to know what we mean by this? Here's an example. You need to maintain a list of organization-approved commercial software components. All right. And a lot of it is, you know, maybe stuff that you haven't been doing, but you should be doing. Well, now this is saying you're going to have to attest to this. So that's all I wanted to talk about attestation. Just know that it's gonna be coming, and it's probably going to be there forever. Eventually, it'll probably go from self-attestation to creating an audit trail. But they're crawling before they walk and walking before they run. Any questions before I do my 3 predictions for 2024? Yeah, go ahead.
You were talking before about composition analysis. How focused have you, like, in your experience, noticed organizations, or how concerned are they about like regional affiliations and dependencies?
What, regional affiliations?
Yeah, like sanctions.
Oh.
If Russia turns its internet off, you don't get patches.
Oh.
Getting patches from Russia, you have a different problem.
Yeah, I mean, the procurers are very concerned about that. And not just in the United States. When we have international customers, I go into those international customers and they're saying, number one, I mean, they want to know provenance. Like they'll have a dashboard of what country this stuff is coming from. Yeah, it's really important. Other question? Yep.
I had a question about naming your SBOM. If you are not, your vendors are not under other government compliance requirements to provide it, and whether you recommend getting ahead during contracting to get those obligations from them.
Yeah, it's being handled even on the government side by procurement, but except that what the federal government is actually saying is to make it easier on everybody, we're going to have every agency in the government use the same procurement language. Thank God. Right, I know. But what we're seeing in industry, especially regulated industry, I'm not as familiar with financial services, but I'm pretty sure they're going to do it in financial services. They're certainly doing it in things that are related to personal safety. So things you drive, for example, that type of thing. That they're putting it into contractual language. And it works its way through procurement. Yeah, Manish?
What do you think is going to, I've been talking to some people about this, where they just get a stack of SBOMs. You have a stack of SBOMs now, and now you have a bunch of things that you have to sort through again and prioritize. Mm-hmm. So, can you talk about how you see people doing that well, or where you see that going, or mm-hmm. how we're not going to repeat what we kind of have with CDs
sure.
and whatnot?
Yeah, so what Manish was asking was, how do you control what happens when you get all these SBOMs? So, very good question. We've been thinking about this quite a bit, talking to a lot of people about it. And certainly federal contractors have, because they stood there going to the federal government, so we're going to give you this SBOM. What are you going to do with it? What are you going to do with it? Because that will determine, what we put in there and all that. And by the way, what you put in there is very important, because do you want to put in the fact that you have a component from a contractor who you have a private relationship with? I mean, there's certain ways that an SBOM could reveal business relationships that you may, so there's all that kind of stuff. But anyway, the big issue is, what do you do with all these SBOMs? And what we're calling that is SBOM management. And there is work now going on to automate that entire process. The Department of Homeland Security has weekly working groups. I mean, they've been meeting every week for over a year. I sit in on these things. And it's people from all over the world, industry, to talk about all those things like everybody in this room has raised. How do we do this? And here's what people are saying. We need a uniform way of sharing the SBOMs. And so the first thing is, how do you get the SBOM? Does somebody deliver it to you, or does the supplier post it in a controlled environment that only certain people have access to? And if you have the credentials, you pull it, all right? So you have to be able to get it to the procurer. Then the procurer has to have a repository set up to receive all this. And you probably don't want it to be a flat repository, right? You know, I mean, these SBOMs, they have a hierarchy to them. If you are an automotive manufacturer, you know, you might have your infotainment system. Well, that's comprised of, you know, your mapping thing and your Apple Play and your this and then each one of those has an SBOM, and each one of those has SBOMs. So you kind of want to maintain that hierarchy so that you know that if this thing at the top has a problem, you can go down the tree, or this thing on the bottom has a problem, you can go up the tree. So you want that. So you want aggregation. You probably want to maintain the hierarchy. You also need to be able to query this repository to say, I have 10,000 SBOMs. Which one of these has this new vulnerable component that just got released? The new CVE came out. I got to find all these things, right? I got to find all them, see who delivered them to me. I have to have a system to go back and contact all those suppliers. And then the other part of it is what I just talked about was querying it, like pulling that information. Wouldn't you want it to push information to you? Wouldn't you want it to automatically, like, you know, go through all of those CVEs and say, oh, there's a new one. Let me go through. Oh, look, that one right there. IT operator, you know, has it. So those are the kinds of things that are really in the very early stages of being developed internationally. I talk to big companies around the world, and these are the kinds of things that they're, and expect that to be a really boom of automation in the near future. So speaking of the future, my predictions for 2024. The first is that SBOMs will be required by almost all industries and almost everywhere around the globe. Producers will need to produce and disseminate those SBOMs. Procurers will need to receive them and verify that they're accurate. We haven't even talked about that. Verification, and then manage them, which we just talked about. And that the operations, the IT operations, will need to be able to regularly use that SBOM data in vulnerability management, which is what I just talked about. Second prediction, attestation. You're going to have to attest that your software development processes were secure, that your supply chain is secure, and that you are ready to respond to post-production discovery of vulnerabilities. And then the last one is the impact on business. This is not just a technical problem. This is hitting at the board level. This is considered a business risk because for a couple reasons. One is that if your supply chain, your software supply chain gets attacked, you're going to lose money. You're going to be out of business for a certain period of time. So you're going to lose money. You may or may not lose reputation, but it's going to affect you. And so it's considered a business risk from that perspective. It's considered a business risk from a liability perspective for the things that we talked about before. And so it's getting attention at the highest levels in an organization, and it's going to be considered a business risk. And the governance people are going to come in and basically say, okay, how do you control that risk? Well, we need policies, we need conformance to the policies, and we need to be able to attest to that. And then we're kind of covered, at least legally. So those are my predictions. I'd be happy to answer any other questions that weren't asked, and there's how you can reach me. Yep.
I'm a little worried that people will get more distracted by SBOMs by having to go to the whole management process now because of the velocity of change.
They'll get more what?
The velocity of change around the software.
No, I didn't hear the first part. They'll get more what?
even more distracted by the
Oh,
SBOM management. And so, because I think one of the things that triggered it was SolarWinds, but all the SolarWinds backdoor beacon command and control software was probably less than signed. SBOM would have done nothing for that.
yeah, so you need, I agree with you that, you know, it can be very distracting, but that's why I think that it's going to be automated fairly quickly. It's not rocket science how to automate this. I mean, it's a solvable problem. It's just that people have been doing this manually before and at a smaller scale. It's never been scaled up like this. So it's, you know, I think it's just going to be automated. Just think about a car recall system, right? You know, the parts recall in a car. They can track, you know, a 1998 VW, right? And, you know, and what part was, you know, became an issue, and then do a recall notice. And so, you know, it's going to be that way for software. Back there?
Do you have any tips for for young software companies that have a lot of code but might not have dedicated applications for the team, might not even have a coding department, kind of how they meet these requirements?
So you're asking, are there tips for a developing software company that doesn't have what?
Do you have any tips for if you're a really small team, you might not even have applications for your team, but you have to kind of code in your environment? What would be your recommendations for going about?
It depends, you know, it depends on who is using your code, right? So, and how important it is to your business. So if you are developing something that is in a regulated industry, you are going to have to bite the bullet and do the things that are needed, you know, spend the money, because you're not going to survive. You're not going to be able to sell in that environment. If it is software that is not in a regulated industry, then it really depends. Then, at minimum, you should have policies. Somebody should spend the time to have a policy in place, and the software development team should understand what that policy is, and everybody should buy into it. I was going to say you should have a security champion, but when you have a really small team, I've been there. I've had small teams, and you know, I had a startup. We had like 9, 10 developers, but you need to have everybody be aware of it and be part of the security process. And then finally, there are open source tools out there which aren't as good as commercial tools, but they'll get you someplace. And check your code with the open source tools, and so that at least you have some exposure to this, and your software development team understands it needs to be done. Yes.
Any insight into how the U.S. government is going to handle the legacy stuff? About code being developed and being written for releases, but we're running, you know, in our industrial control systems globally, stuff that's 20 years old.
So the initial government information said that they were going to go back to 2021, I think. You know, but I think it's really, I don't have any inside knowledge in this, but I'm going to, having worked for a major aerospace company many years ago and for understanding how these things work, I think that they're going to start with the mission critical systems. If you're a weapons system, they're probably going to want this, right? So it's going to start with the mission critical systems and then work its way. On the other hand, they may take the idea that, well, one of the biggest software consumers in the United States is the Veterans Administration, right? And you know, maybe you start with your biggest footprint. I don't know.
Okay, thank you.
Well, just in regards to like the liability of like if it's not being followed properly, since you've been in those rooms and deals, is the viability still being pushed out to the CISOs or anything else, or is it still going to be a company-wide kind of liability as a possible responsibility?
I think the liability is going to be at the company level. And Jace is telling me I have 0 minutes and that I am done. It says done. Thank you very much.